Right, thank you very much for coming. It's past 5, so I do appreciate. And right, the first thing why it's changed, because when I created the presentation and I sent, it was accepted. It was good, but some people got me feedback that what are you going to talk about changing the configuration of a hardware machine or something like that. And then I realized that it's not very straightforward, because we just have one service per one machine, right? Per one VM. So that's why we interchange services and machines. So actually it will be about changing the service configuration layer, not changing the I don't know, installing packages or something like that. We won't be doing such things. So right, so just a brief. Yeah, you can leave now if you want to see something about changing packages. So if that works, all right. So short agenda. So with the short introduction, I will just briefly, really briefly, say about what I'm doing, what the background is, and what I have learned, and what were the problems. What do we do at TomTom? And I will tell you about the problems that we had with the configuration changes. Why did we even think about changing configuration in 2 minutes? How we tried to solve the problem, how we do manage now, and at the end I will do a small demo on a demo application, showing how actually that works, right? So because no one is really saying how to put all the pieces together. So with the short introduction, have anyone heard about TomTom company here? Anyone? Alright, few people. So it's mostly known by the navigation devices, and that's not all the true. You are now moving into the services more. The PMD devices are no one is buying them actually, so we are more moving into the maps and routing and navigation services. Our services are already part of the Azure platform, so you can, if you are using Azure, you can use navigation and routing services inside Azure. And well, the main thing inside is that all those services regarding this navigation, geocoding, reverse geocoding, traffic, all the other things, they rely on a map. And there is a department called Maps in TomTom that actually manages a map. And there is more to a map than only road network that you probably all have seen in the navigation. There is addressing layer, there are signs, and there are points of interest. So you want to navigate into some shop or somewhere else, and there are 3D building footprints. If you are new in the city and you are navigating, you want to have some characteristical points that you want to navigate over and be sure that you are in the right place. And nowadays we are working on a HD map which will support autonomous driving. It will allow autonomous cars to be able to think ahead, to know where they are with the up to the centimeters precision. So on which lane I am, are there going to be any curves ahead of me? Should the car go fast, or should it slow down? Should it reduce the gear? It's both for performance of driving and for ecology, right? To save fuel, right? So there is quite a lot of content in the map, and we do manage the map as on our transactional map making platform, and it's transactional, and we do use Postgres databases underneath, because they, as previous talk explained, they are good for persisting and the transactional things. We do use special functions there because you are interested in particular area, right? So if you are changing Warsaw area, then it's spatial. It's all the data. The first class citizens are the special data that is put in a space, right? It's attributed and associated, but still everything needs to have a position where it lies. What kind of word does it show? And yeah, there are plenty of them, right? We have every road almost in the world is represented in our database, and besides roads there are other objects like countries, like even forests, even cities, other things, and it's all attributed and it's stored and changed transactionally with quality assured, right? So just to give a rough estimate, I'm not saying that it's big or small. I'm just want you to know what I'm talking about. So I'm talking about around 800 million HTTP calls daily with about 20 terabytes of zipped data sent over HTTP. I'm not saying it's a lot or small. It's just an anchor where we are and what we are doing, right? So so it's not an easy thing to change configuration of 1,000 machines, but it's doable in 2 minutes with trackability. But why would you even need that, right? So I will try to answer that, and one of the reasons is why our traditional let's say flow of deployment and application development is like oh no, not that button. All right, here. So you start with your code, you do deployment, local testing. It's fast to that area. It's very fast. You are on your local machine. It's good. Then you get a review. It tends to be slower because it relies on other people. Then you get into the integration testing on the component level, and well, that it also can get tricky, right? It's easy, but it depending on the component and how many things does it integrate, it can get slower, right? Then you can merge, it gets released with other people that have managed to pass the integration test. Then in our environment, you need to do Puppet changes, or they are semi-automatic. If you are doing just a simple release, you have changed the code without anything impacting and impacted in the environment, right? You didn't add new endpoints that your system relies on. Then it's really straightforward. Then a small environment is set up. You do your integration testing of some level higher with other crucial components. That's how we work. And then you create AMI images for your ASG, and then you probably do a rolling deployment because you don't want to hit all the servers with the new version, right? So you do a bit of rolling deployment, and you do monitoring, and then your deployment is done. Right, so this part can take from hours, I guess. The best do it below hours, right? But if you have a big component, it takes hours or even sometimes days to do that, right? And imagine that you have developed a new functionality, and well, it has some configuration, but it works on your computer. But probably on your computer everything works, and you want to ship it to production, and imagine that those values are wrong, and while you deploy it, it's wrong, and then you have to do the whole cycle again to change, let's say, a connection pool size from 10 to 20, right? And then you do that thing again, and well, it's still wrong. So you do the third iteration, and yeah, that's one of the scenarios why it's wrong. But it's it's costly, but it's okay, right? But let's say you have created a bug fix, right? You have bug fixed something. It runs on your computer, of course. Both versions work on your computer. The fixed one works. You do the whole thing. It hits production, and it's wrong. It it solves that 1% of the issues that you got a ticket, right? But it actually stops the whole platform, right? And since it takes like at least few hours to roll back, right? Because you haven't noticed that you can be lucky. It doesn't work from the start, and when you do rolling deployment at 10%, you see it's completely wrong. Then you are lucky, you stop, you revert, but you can be in less luck when actually you have deployed and 2 hours later it's 6 o'clock and you want to go home, but someone says that your change have broken something, and then it needs to be rolled back, right? So that's the reasoning why we have we want to be able to do things faster, to do those experiments, to do bug fixing faster. It's not about deploying to production faster, but being able to experiment or react faster. So that was one of the reasons. And the second reason was that we actually have started as a few years back, 7 years back. It have started as a proof of concept of the map platform, and let's say it's a startup. It ran it on maybe 2 machines with 1 database, and it was operated by some guys from other department, the hardware department. They were giving us the hardware, but they said that mindless baboons, I mean developers, cannot manage the hardware, so give us your components and we'll deploy for you. So they did something with Puppet that was able to deploy the small tiny application, and many of those small tiny applications, it was working well. But then someone decided that this proof of concept is good enough to be backbone of the whole map making department, and we have 2 years to roll it on production. So actually we have estimated that we need 5 years, but they still said that, I mean the whole project was designed for 5 years and we needed to do it in 2 years. And well, it was fixed time, fixed scope, so wonder what have been cut. You know, if you have a fixed time, fixed scope, what do you cut on? Quality, yes. Oh, experienced developers. And right. So we didn't have time to we just grabbed, we said to those guys that were doing deployments, hey, give us the tools, we'll just do deployments on our own, because it wasn't scaling, right? Because now when you have such a big project, you just grab any developer that is walking around and you throw them to the project, right? So we increased the capacity of the development. We started developing more functionalities. We wanted to deploy faster, but there were those 2 guys deploying that thing, and they were not capable of changing things. So mindless baboons started to dig into the Puppet configuration. We just started adding and overriding, and the Puppet was homegrown. It had its own configuration file and its own very special parser for that file. So it had some capabilities, but they were good for 2 services, not that much services. So with that, we started building the platform, bringing more and more content to the platform, more users. So we actually needed to have different setups, and I'm only talking about the core component. There is this core component that is doing the transactional map making. I'm not talking about the QA services, reference services, other things like workflows, project management, and other things. I'm just saying about the core component that is kind of undividable. It's a, let's say, a versioned database component that does scaling of reads, writing, and yeah, that's pretty much it, right? So with actually to fulfill requirements, like, because there are different requirements. If you want to edit a map and you are a manual user, the guy that sits in front of the monitor, your time is valuable. You cannot, your time is you are being paid for your time, and you do things, so it must work really fast. So the latency of each operation must be limited. But on the other hand, there are automated tools that, for example, get data in the bulk mode and they apply it, right? And that automated tools, they don't need to fast response, but they need to be optimized for high throughput. So to do many operations in the shortest period, but it doesn't mean that the operation needs to be fast. So with that, we ended up with different environments, that sub-environments, subclusters that have slightly different configuration. And actually, to get into that complexity with different settings, imagine how much experiments we had to do. And it was all during the migration when we had the time set. So with the heavy process in place, with not a very good deployment tools and not much time to fix it, well, we started cheating. That's obvious, I think. So back then we used HA proxy for load balancing, and so to conduct our experiments on production environment, because that was the, I mean, don't get me wrong, we were doing the local testing, we were doing the automated test, the random tests, random load tests, all those things, but our production traffic was so unpredictable, and we didn't know that much about the platform and the traffic and the things, because we were migrating, right? So we actually started to get machines from HA proxy and CSH to them, and change configuration and restart machines on the fly. So when we started doing it, we kind of got really up to speed with that. We were able to get settings really fast, right? So we were it took days. Still, it took days to experiment, observe, and monitor. But we were doing many iterations during that period, right? But the thing is that we had no traceability, absolutely no traceability of what is going on, what is the state of the cluster, who did changes, who. I mean, there was something deployed, but is it still deployed? Is it changed? Does the configuration in Puppet in repository say it's true, right? No, it doesn't say it's not true. So some incidents happened. I mean, we are not saving lives. It's not that someone died because we have changed the configuration. It's not high-risk system. I mean, I don't yeah, someone could got into the lake because the road was not in the right place, but now we didn't get such reports, right? Those things happen in navigation world, right? I know, but it wasn't the case. So and that thing actually worked until we had more than few hundred machines. At the peak of we were adding hardware to, because we didn't have time to solve problems, so we were adding hardware, and in a short time we ended up with something around 1,000 instances of a core service, and we only think we had to experiment was CSH to clusters. So it didn't work really. After you have 3 monitors and all of them are 2 lines, and no, it doesn't work. So so we started backing up from that, and there was this traceability problem, and we moved to Amazon in that time because we had a own data center that we exhausted resources, and they were not able to build more space into server rooms, so we needed to go to AWS. And with that, there was one more thing. Everything was DNS based, so the dynamic configuration, according to guys who set up the deployment, was to change the master server, the master DNS configuration, right? So if you don't have access to the DNS because you are a developer, it makes things not that trivial. So with move to AWS, we started using Consul because it has the nice interface. You can register your services using HTTP API, but then it can pretend to be a DNS server. So when you register your services, nodes, and stuff, you can get query using the DNS endpoint. That's how Consul works. So we started using it. We of course had problems with scaling the Consul because we didn't know how that works. So we installed the one machine and say, everyone connect to that machine. Yeah, it was working fine until we got into the certain level of machines. Then someone said, oh, the machine is not performing well, so add 2 more nodes, and then it was performing well, but still we were increasing the number of nodes, and it still didn't work. Then we learned that it's a distributed system, and except for a master quorum, you can install agents on the nodes, and they only get replicated, so you don't have to connect with each request to the main server. Wow. Yeah, so we got the Consul working as a service discovery for poor using the DNS load balancing, right? So if you have more nodes under the service and you ask for a service, it gives you the random node, so it works as a load balancer, kind of, right? And but then we have noticed that there is more than a service discovery in Consul. There's something like a key value store, and well, this key value store is like you write to master and it gets replicated pretty fast. You don't have to care about it. So we started thinking, going around it. So we kind of like the fast cycles and changing on the production, but we didn't like the lack of traceability and the conflicts, because when I was doing something on one cluster, then someone else was doing something also on the cluster. He was restarting or redeploying, so it sucked, right? So we needed to bring some order to that chaos that we have created, and we have this homegrown solution. So we don't do changes to context files, to properties anymore. We do actually have a Git repository inside, which is our master for dynamic configuration. It gets on demand. If you want to change something, you create feature branch, you change your settings. You use Jenkins job to push values into the Consul key value store. So the Consul is our transportation medium, and as I said, this is distributed, so it does the heavy lifting of propagation, failover, and other things like that. So only thing that we have to do is to make sure that our services can read configuration from Consul key value store. It's that simple. I mean, there can be there is a Consul template thing. I don't know if anyone you know Consul, right? Consul template. So you can actually populate your configuration files with Consul template, and it will like restart your services if you want to, or reload. We didn't like it because then there is this problem of like you change something and all the services go down and they restart. So of course there are solutions for that, but it needs some manual work. So we kind of sticked with we made our applications aware of Consul key value store. We gave it some abstraction. So when you are a developer and you are inside the code, so you can ask for the dynamic configuration instance, and you just ask for the configuration, and the framework does the population and changes, and our homegrown solution gives out the traceability using Git history, and right. So that's how it works. We have a Git repository with the state, and this gets populated, and it actually gets populated in something around 50 milliseconds, but the presentation is about 2 minutes, right? So we didn't want it to have all the machines get the configuration as fast as possible, because it creates a wave effect, right? And if you are doing changes on the production, let's say you want your 1,000 machines to connect to new database, it sucks, right? So we the databases don't like that, so we have this smooth period of transition. So every service is needs to reconfigure itself from 1 to 2 minutes in that window. So it gives first of all, it gives you time to roll back. So if you push something and you realize you shouldn't do that, then you have 1 minute to roll it back before they see it, and then they gradually start to pick up new configuration, and with that we are able to send those changes and observe them. So anyway you have 2 minutes, so it's really nice on graphs, on the monitoring graphs. If you have broken something, then 2 minutes after you have done it, you can see that, right? So we do different configuration changes. So as I said, values, some values that you're not sure of and want to experiment on production, then you make them dynamic. You just send them to production with default values, and then you change them if you want to. We also do feature toggling. So we use a library called ff4j because we are in Java mainly. So we use feature toggles for J, which are connected to the dynamic source. So our approach is that every bug fix, every new functionality, every change to existing code needs to be sent on the feature off. So we do deployment with the feature off, and then when all things settle after the deployment, because other people have also deployed, so then in isolation you can turn on your toggle, let's say on half of a cluster or 1/3 or something. We do gradual, starting with those automated tools that are not that important, up to users that can create escalations. So we try to protect them. So we toggle on only for manual users when we are sure that it will not break anything. So right, so we change values. We do send feature toggles, and with that we've been able to kind of do that faster cycles, right? The deployment and changing the deployment is one thing, but even with very good deployment, it still takes hours, right? And with that, we are able to do that in less than hours, right? So if it will work, I will do a short demo of how that really works. Right, can you see, or should I use the presentation mode? Okay, you can see, then I assume. So I have here a very simple application. It's a Spring Boot application, but actually it uses our dynamic config facade, which, as I said, has this minimal and maximal refresh times. So each of the machines picks the time at each of the refresh time. It's bound to a certain box, right? But it's not the same for all machines. And as you can recall, the graph I was showing about how the one component is put into different, not roles, but is treated differently. It has different configuration. So those three things are responsible for not the app name, the one. So we have an environment which we are in. I mean, don't we call environments something bigger than clusters, right? So we have production environment, and inside that production environment we have environments for editing, for QAing, for QC, for bulk reads, and we also have environment for our special customer, right? That needs to be treated better than our regular editors. They need to have better latency to show how great the product is, and they should buy it. And we also have Korean environment, which is completely different, because according to Korean law, I mean the good Korea, not the bad Korea, right? Even the good Koreans, they have this law that you cannot take the map out of the Korea. So we actually have a data center in Korea, and all the map data related to Korea is put there. So, but we still need to manage the configuration, which is totally different than all the other environments. So since this is a Spring application, we just create a config factory, and it's magically accessible in our controllers. So basic example of non-dynamic configuration is a very simple controller that returns only static data, right? So it's somewhere here, right? But it's not interesting. The first dynamic thing is here. So we, as I said, it's Spring, so it's magically auto-wired. So we have our facade. We can bind into the property with, as I said, reasonable defaults. So if we have reasonable defaults, and that's all, we don't care. But the thing is that we need to get the value every time an action is conducted against that part of code. Don't worry, it doesn't ask for it doesn't do HTTP call underneath. It's actually cached in the memory, and it's refreshed on rate. So given that, so if we ask, not that one, oh, I didn't put the dynamic, right? So in the default mode, it returns something that was default, right? So I will get this key, and here is the console web UI. We don't use it on production. It's locked. No one can access it. But I wanted to shorten the thing. On production, we just populate it with the guarded job. It's the only one that has access. ACLs is one of things that console provides, except for service discovery, the key value, ACLs, and the newer releases bring even more things, right? So inside my applications key, I will create a new key with value atmosphere. Oh, for some reason the OK button is here. Right. Yeah. I'm pretty sure that the guy is not from Europe for some reason. Oh, okay. So as you can see, it just magically was changed into a new value. So you as a programmer, you don't have to do anything. You just use the library and that's it, right? So except for simple simple getting the values, of course your changes might be heavier. So for example, we do use it also to do operations like switching the data sets. Let's call it like that. We change data sets using dynamic configuration from time to time, and it actually involves more action than just changing the value. When the configuration value is changed, we need to invalidate some caches, initialize new caches, things like that. So there is a possibility to add a callback, and that callback, it just notify you get your code is being notified about the change, and you can react it in an asynchronous way and then change the value, and that's the simple implementation here. So the controller is returning the value, simple primitive value that is being updated inside the callback, right? I can also change the value. Oh, that's unfortunate. All right. Did I do it well? No, I didn't do it. As I said, the navigation is rather strange in the console. Anyway, if I yeah, so it already changed because it was only 5 seconds, right? It's just a demo, right? You should do something more spectacular than sleep for 5 seconds, but still, I think you get the point. And last but not least, is thing that we currently, after the migration phase, and now that we have stabilized the system, we use feature toggles, and we use them on a daily basis. So every time we want to have something changed on the production, we do as following. We create an interface for the functionality that was broken, for example. So there is a let's say a business logic that was broken, and as a default we create the buggy business logic that implements the business logic in a way that it was working, right? So for example, we have noticed that the values do not match, so for A it returns C, and so on. You get the picture. The one important thing is that actually with feature toggles you can create the more complex behavior. The previous one that I was showing, it was simple key value stores, and if you have only one key to be changed, then it's okay. But here you have 3 values, and you don't want them to be asynchronously mixed, right? So if you change A, B, and C, but the service didn't see or didn't update, right, then you can be in trouble. You can get inconsistent changes. But with the FF4J and the interface thing, you are on one implementation or the second implementation. It doesn't have intermediate states. So this is our primary implementation, and there is our fixed business logic that returns good values in our understanding, of course. And the whole interface is very simple, but it has the annotations that actually this is the feature flipper name, and if it's false, then it's false, and it falls to the default implementation. If you change it, it goes to new implementation, right? And this is the implementation name that should be put under the toggle. Okay, so we can see that it's wrong, right? Obviously it's wrong, but so we will try to fix that. No, it's all right. So it has it needs to be prefixed. Right. It needs to be prefixed with Right, so with that in place, the whole implementation was changed under the interface, and now we are good to go. Of course, if you are in a production environment, you have changed your implementation, you think it's good, but maybe there is a client application that you are not aware of, and this application has already known that you have a bug and did a translation. If you return A, it translates it to C, and now you have broken the actually compatibility of with some client that you are not aware of. So we do those things smoothly. We can write about smooth transitions. So the dynamic configuration here is overridden at the application level component, but we can because as I said, this application it has an app name, but it also has an environment. So let's say that for applications in that environment, I will create now the subkey, and inside that key I will create so it for that only part of application. Of course, I have one, but if there would be more than this one instance with different configuration, I can alter the configuration very fast with different things. And yeah, that's I think it. Do I have yeah, so as an no, that's very nice of right. So those things I have talked. So we have feature toggles. As I said, we also change data sets from time to time, and we do love to experiment with the values using that. And even now we have built on top of this configuration a monitoring device. I wouldn't say a framework. It's open source. You can check for James monitoring, but we use it on top of the configuration because with that we can again easily reconfigure monitoring for subsets of machines. So if we want to we use the heavy lifting of configuration transferring using the Consul and dynamic configuration, and James is kind of a dynamic library for wrapping around methods and getting the invocation metrics. So yeah, it's kind of there. We use it, overuse it. Okay, so that's basically it. Questions? Nope. Thank you.
Although maybe there are. Yeah, there's a question.
I've got a question about the data propagation between Jenkins to the console cluster.
Mhm.
Do you send the data directly to the console cluster?
Yeah, using HTTP calls to
Okay.
using HTTP API. There is a key value
Yeah.
API, and you can add key, modify key, delete key, and you can do it even in transaction.
Do you use tags in services
Uh,
or
yeah.
key
So
value?
for the the thing that we use is key value store that doesn't have tags, and we also recently started using the service discovery from Consul, so the applications are aware of Consul and are aware of nodes inside the service, and they are tagged also. So we do tag master server and slave servers for using the Consul service discovery.
So you don't use any kind of tags for key value store because you
No,
can create trees with tags.
Okay, no, we don't.
Okay.
Mm. Okay,
Oh.
here.
You've mentioned console templates as
Mhm.
a tool that you evaluated at one time and said that you didn't like the fact that it can automatically restarts the service. Did you also look at convd, which is a kind of a similar project of allowing you to fill in configuration values from different types like console or etcd or something else? But
Mhm.
it can actually, you can avoid restarting your service if you like. Did you look
Okay,
at
so
convd?
no, we didn't, right? And I wasn't even the one that choose the thing, but I was around, right? So we use archaius from Netflix that is also on top of the configuration sources. But yeah, we use Consul as a main property source. But so convd, right? Yeah. Okay. I'll check.
Also, your team is actually quite prominent and talking of Postgres conferences. So
Yeah, it's
use console and use Postgres, so use Patroni.
yeah. I
Short
mean,
advertisement.
yeah. Yeah, they are. The guys from my team are attending conferences, and I saw them on the picture. So, yeah, there's another question.
One simple
Bless
question: do you have some kind of inventory of all the tags and features that can be enabled and disabled? Not to get lost with it.
That's a tricky question, right? No, it's in the teams and developers' responsibility. We try to do penalties based on the length of your feature toggle. So if you had for example, feature toggle that was longer than 2 months, you couldn't merge any new code into the repository. It worked well, but then someone escalated, and we needed to push him through. And yeah, it is a problem of we try not to reuse feature toggles. We try not to reuse configuration values, and but occasionally, from time to time, you can reach an area of code with the feature toggle that you know it's turned on in production and no one have deleted it, probably because of the tests that would be need to be removed also, right? So yes, it's a common issue, and we don't see it as a very big problem. We thought that it will be bigger with the introduction of that mechanism, but it's manageable actually.
I think that's all.
Okay,
So
thank you.
Thank you very much for your talk.
Thank you.